Hello, everybody. My name is Ali Abdi, and I'm going to talk about personalized robot arms in the future cities. As everybody knows, in the future cities, actually, robots will play a crucial role. But the important thing is that actually we need some personalized robots, not general robots. So, personalized robots actually are based on the ordinary people desire based on their preference, based on their needs. So it means that every person in the future city should be able to personalize, to customize their own robot's arm. But the problem is that actually, uh, ordinary people don't have any knowledge about robotics and about programming. How is it possible that actually we make them enable to personalize their own robot? The solution is using learning from demonstration or LFD. In this project, I'm going to talk about LFD in details. Let's go. So, LFD is a concept that we can use to actually train our robot instead of programming. It means that we can use some demonstration. Everybody, even a person who cannot actually, who don't know anything about the robotics or programming, can show something or can talk to robot or even can interact with the robot to teach the robot what they need. So in this regard, we have three different methods. First of this is actually computer vision methods. That means we can use pose detection, object detection, or any other computer vision based algorithm to analyze the demonstration. The other method is actually using human actually interaction, human robot interaction. So which means that we actually human can use joystick or other devices like virtual reality or augmented reality devices to interact with the robot to show to demonstrate what they need. Another way is using natural language processing, which means that we can talk to robot what we need, and the robot can understand what we talk. But in this project, I just want to narrow down to the computer vision method, not others. So let me focus on only using computer vision algorithms. So the goal can be we can say that the goal of this project is using computer vision to analyze the demonstration of the people, and we can learn the reason behind this demonstration, and robot can understand it and then make a path based on this demonstration. So imagine, let me just use this example for my algorithm, but it's not just specifically this example. We can use any other application or any other context. So it's just for the example of the algorithm. So imagine we are going to cut the branch of the uh, in the farm, in the smart farm. So the the cutting place is somewhere between fruits and leaves. So we can use the pose detection and especially the tip of the index finger to extract the root that we are going to demonstrate. And also we can use YOLO object detection to detect the fruit and leaves in our video, demonstrated video. So if we combine them, we can see that we can have a actually very valuable demonstration that robot that algorithms can understand what is the reason behind this path. It can understand that, oh, the path is should be somewhere between fruit and leaf, and also it should cut the branch, and maybe it should be in the shape of line or something like this. So we need some analyzing methods for actually understanding the concept behind it. But I wanna emphasize that it's not mimicking the path, it's learning the reason behind the path. It means that in any configuration, in every different configuration of the fruit and leaves, robot should be able to generate the best path to cut the branch. I mean, following same strategy in different scenarios. This is the concept that I'm going to actually follow. Imagine we demonstrated some video like right hand side. You can see my hand. I cut a branch in the middle of the fruit and leaves with straight line. So if I generate any configuration of the fruits and leaves with different number of fruits and different number of leaves, or even with different position of the fruit and different position of leaves and different orientation, any scenarios, the robot should be able to generate this orange path. So I'm focusing on this developing method or algorithm to do this. So I in the next slides I will show my developed algorithms that it's actually successfully generate this path. So this is the overview of my LFD architecture. As you can see here, there are several streams. In the upper side, you can see this stream is based on demonstration. So as you can see, there are totally two neural networks. So in the first neural network, first I extract the position and orientation and any other features of the leaves and fruits, the number of leaves, the standard deviation of the distribution of leaves, the standard deviation of the distribution of fruits, the position of them, and also orientation, their orientation, and every feature I extract them using some algorithm like YOLO. Additionally, I use another algorithm like pose detection to show the root, to actually extract the root that I cut the branch. So I use these features to fit the first neural network to learn the concept behind it. This neural network is very important because it's actually learn what is the concept behind this demonstration. After that, the output is actually embedding vector or knowledge space. So I save it and then I concatenate it to the live camera. From live camera, I actually extract the new configuration, for example, new distribution of the fruit, new distribution of the leaves, and their orientation, their position. So if I concatenate behind the demonstrated knowledge to the new configuration, I feed to the second neural network to predict the optimum path. So this is overview of the algorithm that I already developed. So let me focus on each neural network in details, and in the actually next slides I will explain the first neural network and the second neural network. In the first neural network, as I actually already mentioned in the last slide, I first extract the features of the objects like fruit and leaves in the video demonstration video, and also the second one is actually I extract the roots of the demonstration video. I attach them together as a feature vector and feed to the deep learning. This dense neural network, I use triplet loss function to actually train the embedding space. These are very actually very strong and very difficult concepts in the uh, artificial intelligence knowledge. So if you want, you can search about them. So in the embedding space, I use positive anchor and negative samples to make them actually in the same cluster. So this vector, the embedding space is, or embedding vector is my knowledge, that the concept that actually robot can understand it. Now let me switch to the second neural network. Given my result from the first neural network and the live camera, which is the current positions of the fruit and leaves, which is very different from the demonstration one. So I concatenate them together and feed to the second neural network. This one is also very dense neural network, as you can see here. So here we the output will be the route or the path, prediction path. So as you can see here, these are very dense and very, there are a lot of layers, hidden layers. So in this case, we need a large data set. But the problem is that actually generating manually is very difficult. So it's very difficult because we need to draw any different configuration of fruits, leaves with different positions, with different orientation, different size, and so on. But I developed Python code and method to actually generate a large data set. As you can see here, I generated almost 48,000 pictures only by a few minutes, just that can actually cover every configuration of the fruits and leaves, and also um, cutting path. So after that, using this data set, we can train our neural network. As you can see here on the left hand side, there is a loss function of the first neural network, and the right hand side is actually loss function of the second neural network. I can say that these, since they are very dense and very heavy, so in the first neural network took almost 3 days to generate this plot, and this second neural network took 1 day to actually train. So after training, now it was time to test my method. Now I will show you the testing method. So first I run the code. Left hand side you can see my GUI based code, Python code. This is my camera, live camera from top side. It can show my board. So I draw uh, some branch, like there are 2 or 3 fruits and also 4 leaves here, and I wanna use it for demonstrating the cutting path. So I start the video of demonstration and show by my hand that it is the cutting path, and end the video, and also click to the extracting the features of my video. I already actually demonstrated to the algorithm. So it's feature extracted, and then I click LFT to learn what I extracted from features. So now if I press this performing, you can see the path that I showed here, like this. So now let me actually clean the board, and then change the configuration of the fruits and leaves to test and to update the path. So this, for example, this one can be the branch and two fruits and also two leaves. So let me update the path. You can see this is the update path based on the new configuration. So in each configuration you can update it. Let me again update it for new configuration of the fruits and leaves. So this is the branch and this one is fruit, and there are a lot of fruits, like five fruits, and there is only one leaf. So it's totally different from what I showed to the robot, but now you can see it can understand it and then generate new path based on the new configuration. Let me test one more. So this one can be new branch and there are a lot of leaves. So you can see here and here and here five leaves and only one fruit. And let me update the path. You can see this is the updated path. So this one shows that actually I'm my method works perfect based on the different configuration. Just I showed one time one demonstration, but based on this demonstration, it could be actually able to update every possible scenarios based on the same um, concept. So in this regard, I'm actually writing a new paper. My potential paper title is One Shot Learning from Demonstration Approach for Robot Arm Path Planning. So the target journal is Engineering Application of Artificial Intelligence, and the potential context could be food technology. I mean, using robotics in cooking and also learning from demonstration. In the future works, or in I can say in the next papers, I can focus on implementing the method in the real robot, or I can extend my 2D path to the 3D path planning, and also I can add obstacle avoidance ability to my robot. Each of them could be actually a new paper. Thank you for listening to my presentation.